Redrock Study. Complete scenario and full walkthrough. Cases. Welcome or welcome back to this full walkthrough of a complete Redrock Study scenario in which I take you through several Redrock cases questions for you to practice with me interactively. As a reminder, the McKinsey Solve Game currently consists of a Redrock Study, the Solve Game and the Sustainable Futures Lab, which game components I cover for you in depth in this McKinsey Solve Game playlist, which I always keep up to date. The Redrock Study consists of a study part and the cases part. In the previous video of this playlist, I've taken you through the study part of a fully-fledged Redrock Study scenario. In this video, we go through the second or cases part of that Redrock scenario. While the study part's assignments build on each other, the questions in the cases part share the same overall scenario theme, but you will see in a moment that they are completely independent from the study part and that each question is self-standing. Furthermore, recall that to complete both the study and the cases parts together, you have 35 minutes available. But you also have me by your side. I am Jack and I spent 5 years as a consultant and project manager with McKinsey & Company. Nowadays, I serve my clients as an independent management advisor and run this human consulting YouTube channel for you. I know what I'm talking about and I'm here to help. This Redrock Study simulation perfectly matches the real McKinsey Solve Redrock Study, and if you want to prepare further for your Redrock Study game, please check out the links in the video description below. With that said, let us move to the first of the 6 cases questions. As usually, I invite you to first practice for yourself before I reveal answer and solution strategy to you. I am briefly showing you the answer options. You need to select from year 2, 3 or 4 and insert a percentage figure. Read the question and pause the video now. We resume for the solution. You should quickly realize that you can ignore all the gibberish about Arctic wolves and territory growth. All that the question asks you is to identify which 2 of these 60 numbers have the greatest distance to each other on a year-on-year basis and to then quantify that distance in percentage terms. We can go line by line and screen for the largest increase on a year-on-year basis. For Wolfpack A, it is here. For B, it is here. For C, this increase looks the largest, but then you still have this one in D. I hope you quickly figure that the increase in D from year 3 to 4 is the largest one. I would like you to challenge yourself. Just by comparing 700 and 500, can you estimate through mental maths the approximate percentage increase? Especially for your later business case interviews, I recommend that you brush up your mental math skills so that you can run such calculations quickly in your head. From 500 to 700, that would be a percentage increase of 40%. You can see that on the right, during the cases part of a Redrock study as well, McKinsey sometimes invites you to again use its Fiddly calculator. Given the following calculation is rather simple, I suggest you to use it. So let's do that. We can first select year 4, then we calculate the percentage differential. 712 over 503 minus 1 is 0.42. However, it would now be a big mistake to move the 0.42 into the answer gap. In order to make it a percentage figure, we need to multiply it by 100 to make it 42%. Then we can insert the 42 into the gap. If you are not 100% clear about why we calculated 712 over 503 minus 1 and why 0.42 and 42% mathematically exactly are the same, please watch this 5-minute refresher video on the basics of percentage calculation. I hope that resolves all possible questions. I hope you agree that this first question was not too difficult, so this is a cases question where you should bank time for later. Before we move to the second question, for those of you who do not yet know, this Redrock Study mock scenario of course was not offered by McKinsey, but by a developer who in my view provides the best professional McKinsey Solve Game test prep kit. If you'd like to check out both my own free online test prep kit, which you can download immediately, as well as this professional McKinsey Solve Game prep kit, check out the links in the video description below. We move to question 2. You may think that after all that ordeal in the study part of the scenario, suddenly a question without numbers? It happens. I invite you to have a go yourself first, read the question and pause the video now. For a change, in this question the introduction is really important. 2 dimensions are mentioned, 5 different bird populations and the 4 different sub-areas of the forest. Combining these 2 almost screams for a 3rd dimension not mentioned explicitly. How does the size of the populations evolve if you consider bird populations by sub-area? I have created a little example table with dummy numbers for illustration. Answer option 1 is individual pie charts for each sub-area. Well, from a pie chart we can see the distribution of a bird population within a sub-area. However, pie charts are usually scaled to 100%, hence have the same size by definition, and they are really not well suited for a cross-sectional comparison. Pie charts are best used when only one dimension matters. Answer option 2 is a line graph showing species populations with each line representing a bird species. That would imply we needed to draw 5 lines for the 5 birds and then have the sub-areas in the x-axis. To be frank with you, this would not lead to a useful visualization, but just look messy, and information about aggregate bird population sizes cannot be read easily from this chart. As mentioned in the previous Redrock video, line graphs are usually best used when depicting a trend over time, with time in the x-axis. Answer option 4 is a simple bar chart with each bar representing a population of one species in one sub-area. Well, that would not look that simple, but it would look something like this. It would give you a quick overview of the largest versus smallest populations, but it is not possible to quickly infer from this chart the aggregate population sizes, either by species type or by sub-area. This leaves us with answer option 3, the Marimekko chart, which name always reminds me of a Finnish design brand that my sister loves, but well, this is what we want. The chart as described would look like this. Guys, it would be amazing if you smashed the like button of this video, and I invite you to subscribe to my Yuan Consulting YouTube channel for further top quality content on your business and consulting careers. The Marimekko chart is amazing. You can immediately infer from the area size of the rectangles if any bird species dominates certain sub-areas. Additionally, you can quickly figure the aggregate population sizes by sub-area or by bird species type. By the way, I was a bit lazy and created this chart quickly with ChatGPT. With this formatting, it of course would not be client ready. Next question. As usual, I invite you to read the question first and pause the video now. When you read through question 3, you will figure that a new species is introduced to Misty Vale Forest: bees. Unfortunately, this question is nasty and will consume quite a lot of time. For each of the 4 statements given, we need to check if it is true or not. Within the same season, sub-areas with more bee colonies tend to have lower average honey yield per colony. To be mathematically exact, we would need to divide the yields by the number of bee colonies to obtain yields per colony. However, let us save time and avoid these calculations. We start with the smallest colony and move our way up. In spring, redwood produces 22 kilograms of honey with 95 colonies. Marshfield is next with 110 colonies, which produce 2 kilos less honey. Highwood with 120 colonies produces 18 kilos, and Pinecliff with 140 colonies produces 15 kilos of honey. Hence, the first statement holds true for spring. We need to run the same check on the summer figures. The smallest colony is in redwood, producing 21 kilos of honey. Then it is Marshfield with 19 kilos. The 135 colonies in Highwood produce 16 kilos. And the 150 colonies in Pinecliff only 14 kilos of honey. We conclude the first statement is true. Let us move on to the second statement. Increases in number of bee colonies between seasons always reduce yield per colony and vice versa. This statement is kind of similar to the first one, where we had to check yields by colony vertically. Now we need to do it horizontally. The statement is true for Highwood. In spring, 120 colonies produce 18 kilos of honey, but 135 colonies only produce 16 kilos in summer. The same picture in redwood, 95 and 22 in spring, but 100 and only 21 in summer. The statement also holds true for Pinecliff, 140 to 15, but 150 to only 14. In Marshfield, the dynamic is different though. In summer, there are 108 colonies producing 19 kilos of honey. In spring, a higher number of bee colonies, namely 110, does correspond to a larger honey production of 20 kilos. Hence, the second statement is not true. The third statement reads, Marshfield experienced a decline in overall honey production from spring to summer. This is true. Marshfield produced 20 kilos of honey in spring, but only 19 kilos in summer. The final statement. Pinecliff is the most productive bee habitat among the 4 reserves. This statement you should be able to rule out fast as well. If you sum up across seasons, Pinecliff has 290 colonies and produces 29 kilo of honey, but Highwood produces 34 kilos with only 255 colonies. During the Redrock study, sometimes you cannot avoid performing time-consuming calculations. However, given the tight time limit of just 35 minutes, try to be smart wherever you can. Let us take the first and the third answers and move on to question 4. I suggest you read the question first. To have a go yourself, pause the video now. We resume for the solution. We look for the ratio of flatlands over mountains, but the flatlands figure will change. Of course, all area type figures together add up to a 100%. I find it a bit easier to assume the total area size is 100 square kilometers, or whatever area unit. 50 area units are covered by forest, 20 area units by flatlands units, and so on. Forest and public amenities shall be increased at cost of flatlands. We need to calculate the flatlands losses to obtain the new flatlands size after alterations. Forest, which is 50 area units in size, is increased by 4%. Now I suggest you to run the rule of 3 in your head. 1% of 50 is 0.5, hence 4% is 2. I would not use a calculator for this. While forest grows by 2 area units, flatlands are reduced by 2 area units. We repeat the same for public amenities, which take just 4 area units. They are increased by 25%, or 1/4, hence by 1 area unit. The flatlands are reduced by 1 area unit. Flatlands had originally covered 20 area units, minus 2 and 1 area unit losses. This leaves it with 17 area units. Mountains remain 13 area units large, so the sought after ratio is 17/13 or 1.31. We again have this inviting McKinsey calculator on the right side of the screen. Would I bother with it? Probably not, since fiddling around with it costs quite some time. We log in 1.31 as our answer to question 4. And before we proceed with questions 5 and 6, just a quick check-in how you feel about your upcoming assignment. I'm sure quite a few of you may feel somewhat nervous and anxious even during this practice session, and that is fully justified. The Redrock study is tough and extremely stressful given there are only 35 minutes available, and afterwards you still need to tackle the Solve game and the Sustainable Futures Lab as well. So what are your options to prepare yourself for this ordeal? If after going through this simulation you feel already reasonably comfortable with the Redrock study and do not think you need further practice, then you may skip the next video in this McKinsey Solve Game playlist and move straight to the second Solve Game component, the Solve Game. If you enjoy my interactive training style and want to practice the Redrock study further, then I do have a treat for you. In my next video on this McKinsey Solve Game playlist, I take you through 9 further mock questions which resemble closely the second phase of the Redrock study, the cases part. These 9 questions were also offered by McKinsey and were part of a McKinsey mock test for the assessment that McKinsey used before introducing the Solve Game. And there is more I can do for you. I have developed an online test prep kit in which I have compiled many links to free prep resources for the McKinsey Solve Game as well as other online tests. To allow you to prepare yourself for the McKinsey Solve Game, you find there links to several official McKinsey mock tests for its predecessor assessment, the McKinsey Problem Solving Test. You can download my online test prep kit immediately and for free, link in the description below this video. Now, while I always try to dig up the best free resources for you, I want to be transparent about their limitations as well. They are now 20 years old, they are untimed, and while the old paper-based questions share some similarities with the cases part of the Redrock study, its first study part that we went through in the previous video is completely different. For safe passing of the McKinsey Solve Game, this Redrock study simulation I am taking you through was developed by a third-party provider who, in my view, has developed the best professional McKinsey Solve prep kit available in the market. I introduced all its benefits to you in the previous video. Now I just want to recall quickly how it will help you to overcome the Redrock study. The so-called combo package has you covered for the Redrock study, the Solve Game and the Sustainable Futures Lab. It starts with a Redrock study video strategy guide, which is very worthwhile to go through. We know that the 35 minutes time restriction of the Redrock study is brutal, but in this video strategy guide, the third-party provider shows you a cheat code on how you can increase your thinking time available beyond the 35 minutes officially allocated to you. I'm afraid I did not discover that loophole myself, so that I'm not allowed to share it in this video. Then you can go yourself through another completely different Redrock study scenario to hone your analytical skills before a walkthrough video reveals the solutions to you. Thirdly, there is another additional interactive practice module for the cases part. And fourthly, as a brand new addition, the third-party provider has added for you a compilation of past real investigation phase setups and analysis phase questions that have actually appeared in the Redrock study scenarios that McKinsey has dealt to candidates. These will give you an edge for knowing what to expect in your Redrock study scenario. The combo package also allows you to essentially hack the Solve game and has you covered for the Sustainable Futures Lab. But let us focus on the Redrock Study for now. If you feel you may want to practice the Redrock Study further, you can select one of two add-ons. You can either add one Redrock Study simulation to the combo package or two Redrock Study simulations plus another Solve game simulation. And super important, this professional prep kit is so amazing that you only need to pay for it if you pass your McKinsey Solve game. Reportedly, 90% of prep kit users pass their McKinsey Solve game, but in case you do not, the prep kit provider refunds you 100% of your money. In any case, I believe it is worthwhile to invest some more time in your preparation for the Redrock Study. As we said in the previous video, the Redrock Study is designed to assess your quantitative reasoning skills, and improving them will benefit you for all other online tests as well as for the business case interviews that await you at the next stages of your consulting recruiting processes. Download my free online test prep kit and check out this professional Solve game prep kit for yourself. Use the links in the video description below this video. Brace yourself for question number 5. And as you can see, each case question presents a unique challenge, and this one hits different as well. Try for yourself and pause the video now. This question comes with a set of equations which I hope did not scare you. It simply asks which of these 4 equations applies to the data table above. Once again, you can ignore all the thematic gibberish and just focus on the numbers and mathematical variables. All that you need to do is to plug in the values for the 4 given independent variables f, p, v and w into the 4 equations below and see if they produce the corresponding values for s, the depending variable. Let me switch to our whiteboard and demonstrate this for you. I copy the first equation and then plug in the year 1 values from the data table. When you do this, you see that the result that comes out is 800. However, in year 1, s should be equal to 560. We can now already eliminate the first answer. I copy in the second equation. If we plug in again the year 1 values, we find that s is equal to 560, so we cannot yet rule out the second equation. Now we are at a crossroads. We can either plug in the year 2, year 3 and year 4 values into the second equation to check if it holds true for all years. That would imply 3 more calculations. Alternatively, since there is a chance that we will be faster that way, let us plug in the year 1 answers into the 2 remaining equations. If we are lucky, they immediately yield false results and equation number 2 would be the winner. Let me shorten this. That is the case. If we plug in the year 1 results into the last 2 equations, we find that they yield wrong results. We can eliminate them and equation number 2 must be the right answer. You could now, of course, still plug in the values of the other 3 years into the second equation to find out if the equation holds true for all years, but that is not anymore necessary at this point. If I were you, I would save the time and select the second equation, given you have successfully eliminated all other answers. Let us do that and move to the last question within this Redrock Study scenario. Note that you will have to submit 3 answers, and each answer you need to select from a drop-down menu with the same 3 answer options. To make it a bit easier for you to navigate through this question, I have copied its contents to our whiteboard. As usual, read the question, have a go yourself, and pause the video now. As you can see, this question tests your basic knowledge of statistics. If you are not anymore familiar with these concepts, you ought to refresh your memory with the meaning of these 3 terms. What plays out to your favor is that you most likely do not need to compute the exact statistical values. Determining whether they are smaller or larger than 15 will most likely be enough. I genuinely think the diagram is slightly confusing, but that exactly matches the McKinsey style. In all McKinsey tests I have seen, graphs are often a bit weird and designed to confuse the candidate. You can be sure that McKinsey would never show such a slide to a client. What this graph says is as follows. The x-axis determines the number of foxes appearing in a quadrant. The y-axis states in how many quadrants exactly x foxes appear. Let me explain this by an example. Take 4 foxes per quadrant. There are exactly 5 quadrants in which there live 4 foxes. Similarly, there are 15 quadrants which are populated by exactly 26 foxes. Now, what is the mean value of foxes per quadrant? In other words, how many foxes live in a quadrant on average? You do not need to perform any calculations to answer this question. You can see that the bars towards the right of the chart are the highest. Since this histogram is skewed to the right, there must be more quadrants that accommodate more than 15 foxes per quadrant than quadrants that have fewer than 15 foxes per quadrant. So the mean value will be greater than 15 foxes per quadrant. Let us consider the modus, which always is the easiest value. It is defined as the single value that appears the most. We can easily infer the exact modus value from the chart. The highest number of sectors is populated by exactly 17 foxes per quadrant, which is greater than 15. To determine the median value exactly, we would need to add up the total number of sectors that exist. We would then sort all sectors from the bottom to the top in ascending order by the number of foxes they accommodate, and then would check how many foxes live in the sector that stands exactly in the middle of all sectors. In other words, if there were 101 sectors, we would sort the sectors in ascending order by the number of foxes they accommodate and then check how many foxes live in the middle sector 51. Again, this chart is skewed to the right. In other words, there are more sectors that accommodate a high number of foxes than there are sectors with a low number of foxes. That implies that if all sectors were sorted by their number of foxes in ascending order, the middle sector will contain more than 15 foxes. So we can select 3 times greater than 15 from the 3 drop-down menus and finish the Redrock study. Well done, ladies and gentlemen! If you have watched this video until here and want to show it off, type left the island into the comments below this video. Also, I would appreciate if you smashed the like button and subscribe to the UN Consulting channel for further top quality content on your business and consulting careers. Note that in your Solve game, after you have completed the Redrock study, you can now take a break and do not need to immediately launch the SeaWorld game. Hence, calm down a little after the stressful Redrock study before you start the next game. I informed you earlier in this video how you can intensify your preparation for the Redrock study. Links in the description below. Follow me to the next video in this McKinsey Solve Game playlist to practice with further mock questions that resemble the second cases part of the Redrock study.